me begin with a revision of what we have done so far in the past 2 weeks. Now, the first thing is we discuss different types of moments, and the first one is the moment about the point, and the moment about point is our cross F. It is easy, and the second one is moment of a force about a line, because some moments will, for example, if you have a shaft here, that some moment will lead to rotation of the shaft, but some moment will not lead to rotation of the shaft, which is we talk about here. Some moments will lead to rotation of the shaft, but some moments like this one, that is no rotation. Okay, it does not lead to rotation. So we need to talk about how much it will lead to rotation. So we have this moment of a force about a line. Okay, and the last thing is we have two. If we have two forces, it will not lead to translation, but it will lead to rotation. So for these two forces, that there will be no translation, but there will be rotation. So in this case, we say we have a couple. So for a couple, that because summation f equal to 0. So for calculating moments of a couple, that we don't need to put subscripts here. So we don't need to put reference points or reference line here. Okay. So before we ended the lecture on the first day, we talk about force couple system. For example, we have a force acting on something here that it will lead to both translation and rotation. So sometimes we want to talk about the forces on center of gravity. So it will become a force here. It will for at the point of center of gravity. So we will have one force and one couple here. The magnitude of couple is r cos f, and both of them are the answer. So it is a force couple system. It's okay. Now and this is what we have talked about. And now I want to talk about the last example of chapter 3 before we move on. So on page 29, now we have a shaft, and we have a shaft AB here, and we have two pulleys. And two pulleys. And we have, of course, we have belts here. And we have, on belts, we have four forces. And we want to replace the belts. Take a look here in front of you. Replace the belt forces with an equivalent force couple system at A. So we want to express these all four forces at A. Okay. So this one will have a one force couple system here, and for this one we will have a force couple system here, and for this one we have force couple system here, and for this one we will also force couple system there. And so for the final force couple system, the force part is easy because by moving the force from here to here, from point A to point O, the magnitude and the direction of the force is remains the same. So we simply move the force from point A to point O, which is the same here. That is to move this force from here to here, from here to here. So the total force coupled system, the force is the sum of these four forces. How about the couple? We have two methods of doing that. The first one, of course, is by definition. By definition. By definition. By definition, we have that the force coupled system at A is equal to, and let's mark the figure like this. We have point E, point F, point G and H. Okay. So if we have point E, F, G, and H, so we can have suppose we have point E, then we have our E with respect to A cross FE, and we have suppose we have point F here, and then the moment arm is point F R F with respect to A cross F, and so on. But these are quite difficult to do, and if you do this in examination, it is easy to get it wrong. So it is easy to have mistake. Easy to have mistakes, right? So what should we do? We use the second part of our the second part of the discussion. So we first group these because both force E and force F are related to the pulley as B, right? E and F are related to pulley B. And G and H, how about force G and force H? Both of them are related to pulley and C. Okay. So here we have so we calculate the force coupled system. We first calculate the force coupled system. At B, and then we have we calculate force coupled system at C, and then based on these two, we calculate the force coupled system at A. Okay, we do it in 3 steps. The advantage of this is that this is a 2D problem here. The advantage is this is a 2D problem for steps 1 and step 2. These are 2D problems because they are all on the pulley. Okay. I'll come back to the graph below. Okay, but E and F are on pulley B and G and H are on pulley C. Okay. Any problems up to now? If you're okay, then I'll go on. And the first couple system at B, and I will say, of course, we can, because it's a 2D problem, we can simply draw the pulley, and we can draw the pulley, and this one is a point B, and this one at Y, and this one is Z axis. Now we have 250 Newton. And this is on the horizontal line, and for this one is 141 Newton, and this one is now E, and this one is now F. Of course, this is also with right angle, and this one is 20 degrees. And because this is a pulley, so this one forms a tangent with the circle.有没有谁还有两个选？好像有没有谁啊？6. Now, so from here we will get force couple system like B. So we have a force and we have a couple. For the force part, we have equal to 145 Newton, and with this one. Because this one is this is 20 degrees, so it is sorry. This one is J. So this one goes to minus y. This one goes to minus y direction, and plus z direction. So this is minus cosine 20 degrees J and sine 20 degree K. So And for couple and for the couple constant, it is r cos f for the r cos f, and we plus this r cos f. So it is I think it is easy to use because this one is building in this direction, and this one is in this direction. So you can, I would say you can also use you can use 2D or 3D. I'm fine. And what's the radius? What's the radius? Oh, this one is the diameter is 150 millimeters. So this one is 150 millimeters. Okay. So it is RE cross FE plus RF cross FF, and this, because this MB is equal to minus 5.25 Newton I. Okay.这是这方是这个是大的，这是大的是这样子。因为这个是大的，这个小的是哪个是小的，大的那个是这，所以应该是大的是小的。对。Okay. Any problem with that? So, and there is some problem of there's some question on why this is cosine 20 degrees and this is sine 20 degrees. So, and let's have a look. This one and this one is remember this one is 20 degrees. Okay. So this one should be cosine, and this one should be sine, I think. It's okay. So we are talking about the force. We are not talking about the. Here we are only talking about the force. We are not talking about the momentum. Okay. Now if